Ballet and science are not often thought of together. However, like all things, dancers respond to and are bound by the laws of science. In a previous project, I looked at how dancers use physics to seemingly defy the laws of physics. Within this project, I will look at chemistry in relationship to ballet dancers. Chemistry is the study of matter. The study of chemistry, at its most basic form, is studying how matter changes and what matter is made of. Chemistry is one of the foundation sciences of all matter and living things. There are many avenues of chemistry that could be studied in relationship to ballet, but within this project, I will address modern advances in chemistry, specifically in plastics or plastic-like substances that have benefited ballet dancers. Remarkably, plastic and other products derived from the discovery of making plastic have benefited dancers immensely. Plastic, in general, is made from oil, which is rich in carbon. These carbon-containing polymers are made up of repeating units of shorter carbon-containing compounds called monomers. Different monomers can be combined in a wide variety of compounds, giving plastic many different chemical properties. It can be stiff and rigid or soft and pliable. It can be made into fibers. Some of these combinations of monomers became things like nylon, styrofoam, polystyrene, polyethylene, and vinyl. Some polymers were also called elastomers. An elastomer is described as a rubbery material composed of long chain-like molecules or polymers that are capable of recovering their original shape after being stretched to great extents. Vinyl became an important floor surface for ballet dancers. Historically, ballet was danced on a hard wood or concrete stage made for the heavy sets of opera. It wasn't until the 1920s that sprung wood floors were developed for dancers, and not until the 1970s when vinyl floor surfaces were added on top of the sprung floors. Sprung floors offered energy absorption and energy return. When vinyl flooring was introduced, ballet dancers had a surface that now offered slip resistance or traction. Vinyl, also known as polyvinyl chloride, was first developed in the late 1800s and comes from the family of thermoplastic resins, which have the benefit of softening when being heated. It is a blend of polar chlorine molecules and carbon and has an amorphous structure. This amorphous structure, as well as the addition of plasticizers, modifiers, and coloring, give PVC its unique properties. PVC is flexible, elastic, impact-resistant, anti-fouling, antimicrobial, and fire-retarding. Vinyl began making its way into flooring in the 1950s. A company called Marley Flooring introduced the new vinyl flooring for the home in 1952. While finding definite history on the early usage of Marley flooring for dance proved difficult, sometime in the 1970s, Marley flooring became the standard performance surface for ballet companies. What is commonly accepted now is that vinyl flooring for dance is referred to as a Marley-type floor, even though the Marley Floor Company no longer exists. The flexible, thin material dampened the sound of hard point shoes and landings from jumps. The surface allowed dancers to glide smoothly across the floor, but had enough friction to allow dancers to push off into various balances, turns, and poses. In today's dance world, there are several companies that make a variety of vinyl floors with different surface resistance for all different kinds of dance, not just ballet. Nylon and other plastic-based fibers such as Lycra, Coolmax, and Tactile were also critical inventions for ballet. DuPont introduced nylon at a time when Americans had to find a substitute for Japanese silk to make stockings. This became the essential ingredient for a ballet dancer's tights. Dancers needed practice clothes that molded to the body, dried quickly for hygienic reasons, and were flexible enough to meet the demands of the choreography they were asked to perform. In the 1960s, Lycra, the brand name for spandex, a polymer, replaced cotton-wrapped rubber as a source of elastics. Textiles containing Lycra spandex were considered body adaptable. With DuPont's later invention of Coolmax fabric, dancers as well as other athletes were given a more efficient tool to wick moisture from their bodies. Coolmax fabric fibers have a series of small grooves which draw water up in a process called wicking. The force drawing them up is known as capillary action and works because of surface tension in the liquid pulling it up through the tubes. Coolmax fabric, with narrower pores, exerts a much larger capillary force on sweat than standard fabrics, and so is more effective at drawing sweat up from the skin. Today, many dancers will find their practice garments are made from tactile. Tactile, another brand name of moisture-wicking fabric, also adds a benefit of superior color fastness. This allows for brighter colors that don't run in the wash, as well as an environmentally friendly factor. The tactile product uses less dye-fast chemical. One place you probably would not expect to see plastic is in pointe shoes, but it is being used in some dramatically altered ways. Dancing on pointe is dancing on the toes, with only the protection of the hard toe box of a pointe shoe. The hard toe box was traditionally made from fabric, paper, and paste. The shoe also had a stiffened shank under the arch of the foot, connecting to the bottom of the toe box. This hardened toe box and shank must have structural integrity to support the weight of the dancer on her toes. Dancers are repeatedly jumping, and dancers on pointe may be jumping on pointe many times over the course of a rehearsal or performance day. This jumping puts stress on the soft tissues of the body. Since the pointe shoe tightly encases the foot is not allowed to spread out on impact, and the natural shock-absorbing features of the foot are impeded. Historically, the pointe shoe is not designed to have shock-absorbing qualities. Unfortunately, the paper, paste, and fabric pointe shoes also broke down quickly with repeated impact and with sweat. Since the 19th century, pointe shoes have been made the same general way, by hand, with paper, paste, fabric, and leather. Several pointe shoe companies have experimented with using polymers in the toe box and the shank. Schottner, a company from Austria, used carbon fiber in the shank and synthetic glue for the toe box. Chicotte and Bloch brands also used plasticizers in their glue to make the shoes last longer. In the late 1980s, a former dancer began experimenting with plastic polymers for the toe box and shank to create better pointe shoes. In 1993, she launched Gaynor-Minden pointe shoes, made from a patented elastomer. This substance offered longer life to the shoe, better shock absorption, and better health for the dancer over the long run. Unfortunately, Gaynor-Minden pointe shoes were stiff, making them really only good for professional dancers. Personal experience has shown me that many studios banned their students from using them in the early days, as the stiffness made them have a higher learning curve for proper use. Over the last 20 years, though, Gaynor-Minden and many other pointe shoe companies have been experimenting with elastomers and pointe shoes to give dancers a better, healthier product. A new invention on the market is a product called D3O. D3O is a patented non-Newtonian fluid. Newtonian fluids only change their rate of flow depending on temperature or pressure. D3O and other non-Newtonian fluids behave in usual ways depending on the stress that is applied. Adding a sudden stress caused the fluid to act more like a solid. In 2008, a pointe shoe maker patented the use of D3O in pointe shoes. The pointe shoes have apparently received much praise and are now sold throughout the world. The shoe is marketed as specially engineered with intelligent molecules that flow with you as you move, but on shock, lock together to absorb impact energy. Dancers get more life out of their shoes, the shoe looks and maneuvers well, and the impact force on a dancer's body is less, allowing for a longer, healthier career. The discovery of making plastics has benefited the human race in many ways, and dancers are no exception. The use of vinyl flooring, polymers, and non-Newtonian fluids has decreased injury rates, lengthened the career, and accelerated the rate of achievement in dance. One cannot, however, talk about the benefits of plastics without some mention of the problems with plastics. While a large-scale investigation into the environmental impacts of plastic is beyond the scope of this project, an investigation into plastic's impact on the environment would be worth future study. It is important to remember that plastic is an oil-based product and oil is a finite resource. Also, the carbon compounds that make up most plastics are chemically inert and will not have a chemical reaction with other substances. This means plastic does not decay for a very, very long time. Plastic remains in the environment. The best disposal method currently available is recycling. Recent developments in chemistry have found that plastic can now be made from biological substances like corn oil, which would allow plastic to biodegrade much quicker. The world of ballet is breathtaking and amazing to behold, but the stress on the body is unimaginable. Tools from advances in chemistry, such as flooring, shoes, and clothes, are only one dimension of the many the dancers utilize to protect, nourish, and heal their bodies. There is more to study, so stay tuned as I explore nutrition, sports medicine, and biology in conjunction with the world of ballet.